Hello, so today we are going over the topic is formulas, and the goal is I can write empirical and molecular formulas of organic compounds. Okay, so first we need to know what molecular and empirical formulas are. So, molecular formula shows the actual number of each type of atom in the compound. It's not always the simplest formula. So, glucose has 6 carbons, 12 hydrogens, and 6 oxygens. So, the formula for that would be C6H12O6. This is the molecular formula. This is the most common thing that we have seen so far. It tells you exactly how many of each element you have in that compound. Okay, empirical formula. This is the simplest whole number ratio of the atoms. It's calculated by dividing the subscripts in the actual formula by a whole number to give the lowest ratio. So we had glucose, C6H12O6. The lowest number that all numbers go, or the highest number that all the numbers go in is 6. So if we divide that by 6, we get CH2O. So that would be the empirical formula. Molecular formula tells you exactly how many they are. Empirical formula is basically the molecular formula just simplified. So these first 4 questions are in your digital notebook. So you need to make sure you answer these in your digital notebook as well, but I want to go over it with you. So what is the empirical formula for C4H8? So that's your molecular formula. We need to simplify that. Well, we can simplify that by dividing by 4 because 4 goes both into 4 and 8. So that would be CH4. What is the empirical formula for C8H14? So 8 does not go into 14. So let's try 4. Does 4 go into both 8 and 14? No, because 14 divided by 4 is 3.5. So that's not a whole number. So let's do 2. So 8 divided by 2 is 4, so it'll be C4H7 because 7 or 14 divided by 2 is 7. It can't get any more simplified than that, so it would just be C4H7. Okay, which is a possible molecular formula for CH2O? So here is as simplified as it gets. So which ones of these would simplify into this? Well, it's not A, because if you simplify that, it would just be CHO. So not A. B, you have C2H4O2. That would be an option because if you simplify that, you get that. C3H6O3 is also an option because if you simplify C3H6O3, you would get CH2O. A compound has an empirical formula of SN. If there are 4 atoms of N, what is the molecular formula? So here, S has 1, N has 1. So if there are 4 N's, that means you would need 4 S's. So it'd be S4N4. Okay. 3 steps for determining chemical formulas. Step 1. Determine the percent composition of all elements. Step 2. Convert this information into the empirical formula. And step 3. Find true numbers of atoms or elements in the compound or the molecular formula. So we're going to talk about for the rest of this section how we can do these 3 steps, how we can go from the molecular to empirical if we're given the amounts, how we can go from empirical to molecular if we're given the amounts, all that good stuff. So before we can do that, I'm wanting to review over percent composition. Okay, so is the percent by mass of each element in the formula. Calculate the percent composition of CO2. So first I want you to type out these steps. Step 1, find the molar mass, which we have gone over a couple of times how to find the molar mass, but we will go over that again. just to kind of refresh your memory. Step 2, define each individual compound percentage. Divide the total mass of that element in the compound by the molar mass and then times 100. Okay, so let's do CO2. We have CO2. All right, so how many carbons do we have in CO2? We have 1. Times, we need to look at a periodic table and see what the mass of carbon is. If you go to ptable.com, here's carbon. Carbon has a mass of 12.011. We can round that to 12. So 1 times 12 is 12. And then oxygen. We have 2 oxygens. If we find the mass, that is 16. 2 times 16 is 32. We add those two numbers up. 12 plus 32 is 44 grams per mole. Okay, so to find the percentage of each element, we will take the total, so that'll be 12, divided by the molar mass, which is 44, times 100. So I'll pull up a calculator so you can see me do that. We need to do 12 divided by 44 times 100. So that would be 27.27%. We can round that to 27%. That's fine. So 27% of this compound is carbon. And also with oxygen. So our total for oxygen was 32 divided by 44 times 100. Times 100. Try that again. Or we could just do 0.72, move it 2 times, which would be, if we rounded, 73%. Equals 73% of oxygen. So now we have the percent composition of each element. You can double check your work by making sure these two numbers add together to get 100. Now in your digital notebook, in the practice pages, we did the first 4 on this first slide earlier just to kind of introduce. But here you need to find the percent composition of C3H6O3 for question number 5. So if you want to wait till after we've done the whole section and do this problem, you can, or you can go ahead and complete that since that is fresh on your mind. Okay, so here is how we calculate empirical formula when you are given the percent composition. So if you're given percent composition, assume 100 grams of that sample. Step 2, convert mass of each element to make moles. So you're going from grams to moles. Step 3, divide each of these numbers by the smallest number, and then if necessary, multiply by the smallest number to make each a whole number. These whole numbers are the subscripts in the empirical formula called mole ratio. All right, so I know this is probably taking up a lot of space in these notes. If you need to add a slide to take notes, you can, or you can make your text smaller. You can make this text box bigger. You can put it in paragraph form instead of list form, or you can write it on paper and then upload pictures or send me pictures if you're virtual, or just turn your notes in if you are in person. Okay, so here's an example. The percentage composition of a compound is found to be 32.4% sodium, 22.5% sulfur, 45.1% oxygen. So we need to determine the empirical formula. So step one, assume 100 grams of sample. So they tell us we have 32.4% of Na. We just need to change that to grams, 32.4 grams of Na. 22.5% of sulfur is 22.5 grams of sulfur. 45.1% oxygen is just 45.1 grams of oxygen. So that's your step one. We're just making it grams instead of percents. Okay, so convert grams to moles. You could do the stoichiometry listed, or it's always going to be whatever you have divided by the molar mass. So if you want to just look up the mass of sodium, you could do 32.4 divided by 22.99, because if you look at sodium on the periodic table, it's 22.99. So if you divide those two numbers, you get 1.41 moles of Na. 22.5 divided by the mass of sulfur, which is 32.06, is 0.7 moles of sulfur. 45.1 grams of oxygen divided by the mass of oxygen, which is 15.999, is 2.82 moles of oxygen. So that's our second step, converting grams to moles. You take whatever grams you find up here divided by the mass of that element. That's how we got that. All right, so next, step 3, divide by the smallest mole. So these were the 3 moles we found over here. I just listed them side by side so you could see. The smallest mole is 0.702. So we need to divide all 3 of these by that number, and we get close to a whole number for every single one. For this one, we get 2. For this one, we get 1. And for this one, we get 4. Well, that tells you what your empirical formula is. So we have 2 Na, so it'll be Na2. We have 1 S, so it'll just be S. And we have 4 O, so it'll be O4, so Na2SO4. Okay, for this, in your digital notebook, you have one question right here, question 6, where you have the percentage. Question 7, I went ahead and changed it to grams for you, so you don't have to do that for this. You follow the same steps for both question 6 and 7. All right. Okay, so calculating molecular formula from the empirical formula. So you are given the empirical formula. You need to figure out what the molecular formula is. So for step 1, find the empirical formula mass by adding up the weights of the atoms in the empirical formula, and divide the molecular mass by the formula mass. So go ahead and write those 2 steps down, and then I will go over what that looks like and what that is. Okay, so here, now for these examples, I don't have them underlined, but you are more than welcome to write these examples out so you have them to work on. So a compound has an empirical formula of C2H3O and a molar mass of 172 grams per mole. What is the molecular formula? So first, we need to find the empirical formula mass by adding up the weights of the atoms in the empirical formula. So our empirical formula, C2H3O. So we have 2 carbons with a mass of 12 plus 3 hydrogens, and a hydrogen has a mass of 1, plus 1 oxygen with a mass of 16. So that's 43.05 grams. Now we divide the molecular mass by the formula mass. So here they tell us our molar mass is 172 divided by what we got here. So when we do that, it's 4. So that means we need to multiply each of these numbers by 4, and that's how we get our molecular formula. So it'll be C8H12O4 when we divide each of, or multiply each of those by 4. So in your digital notebook, that is question 9. So questions 6, 7, and 8 are the ones where you get the percentage from, and you change it to grams, divide by the molar mass, what we just went over. And then question 9 is the stuff that we just went over on going from the molecular formula or empirical formula to molecular formula. If you have any questions, or even if you just want me to check your work, email me and I'll show you how I can do, and I'll explain how I can do that to make sure you're on the right page, because I know it's a lot of information. This is new. We did not do this in Chem 1. So I'll be happy to help you any way I possibly can.